So you have something like this. They've given a right triangle where this is 3, this is 4, and this is 5, which shows that this is a right triangle, and this is theta 1, and a sine theta 1 is a 4 by 5, and this is the theta 2, and a sine theta 2 is a 3 by 5. A block of 1 kg rests on both the places, and you know mg is going to be acting downward, the normal reaction is upward. This is theta, and so this is mg cos theta, and this will be mg sin theta. And again, if for this block there will be an mg which is acting downward, a normal reaction upward, and so this will be theta, and so then this gets broken to mg cos theta 2, and this is mg sin theta 2. This is theta 1, and you know already sin theta 1's value. There's a thread which runs over this pulley. The tension in both the threads will be the same because it runs over a frictionless pulley. There's absolutely no friction in this. I'm going to assume this to be coming down because this side is more steeper. So I'm assuming the acceleration is down, this acceleration is up. So doing a free body diagram in this, since the acceleration is this direction, this force should be greater than this force. So therefore, let's write mg sin theta 1 minus tension is equal to m1, that is this mass, anyway it's only m into a, because both of them 1 kg. 10 into, what is sin theta 1? 4 by 5 minus t is equal to a. 5 2s are 10, 8 minus t is equal to a. So t is 8 minus a. Let's go to this free body diagram. Since the acceleration is upward, this tension should be greater than mg sin theta 2. A t minus mg sin theta 2 is equal to that mass into acceleration. But anyway, the mass is only 1 here, and so tension minus 10 into sin theta 2 is 3 by 5 is equal to that mass is 1 into a. T minus 6 is equal to a. T is equal to 6 plus a. So 8 minus a is equal to 6 plus a. So 2a is equal to 2, and a is equal to 1 meter per second square. So that's the acceleration. That's all. If you want to find the tension, you can substitute and get T is equal to 7 Newton. Beautiful sum. Let's go to the next question. Next question is that frictionless surface in which there is a block of mass m1. We're applying a force in this direction. They've given some force like that, and it runs over a pulley, and there's another mass m2. And they've given this, this force is m2g by 2. Okay, you know that m2g is the force that is going to pull it down, and there's a tension T and a tension T. Okay, so since this is half the force, initial itself, you know, this is just half this force, therefore it's going to descend like this. This is how the acceleration net force is going to be, and this is how the acceleration is going to be. And therefore, taking this free body diagram, you know, as since the acceleration is down, the downward force is greater than the upward force. m2g is greater than t. So m2g minus t is equal to m2 into a. And taking this free body diagram, since the acceleration towards the right, t is greater than minus f. So t is greater than f. T minus f is equal to m1 into a. T is equal to m1a plus f, where f itself is given to be m2g by 2. So equating both these tensions, let's find what is tension from here is m2g minus m2a. So then therefore, m2g minus m2a is equal to m1a plus m2g by 2. Taking this that side, consolidating the acceleration, a into m1 plus m2 is equal to half m2g. So a is equal to m2g by 2 into m1 plus m2, and that's the value of the acceleration in this. Okay, acceleration of m1 or m2 is going to be the same, so you can write the same answer. Let's go to next sum. You have a pulley which is fixed, and then there is a mass. They're calling this mass as m1. Runs over a pulley, and then this mass is m2, and the m1 itself is 5 kg, m2 itself is 2 kg. And so then the advantage now is, you know, this m1g is going to be greater than this m2g. So I can assume the acceleration is going to happen in the bigger masses direction. Okay, so I'm trying to look at this sum where, but that additionally, they seem to have given some force here F, and there's some force here F according to the diagram. So you have m1 and m2. Find the acceleration of either block draw the motion of M1 if the string breaks but F continues. So there seemed to be an additional force F. I think so. So let's take that also into consideration. You know that there's a tension which runs over this, which will be the same as this. We have assumed this acceleration to be like this, so this acceleration is supposed to be like this initially, right? So this is my assumption. So now let's take this free body diagram. Since the acceleration is downward, the total net addition of these two forces should be greater than this. So let's subtract it. So you know that we have to subtract F plus M1G minus tension should be responsible for this block M1 into that acceleration. Similarly, for the right side, if you're going to take this free body diagram, on the right side, you know its acceleration is upward, so T should be greater. So you know the T has to be greater. T minus M2G minus capital F should be equal to M2 into A. So with this we can equate both the tensions. It's F plus M1 into G minus M1 into A is equal to tension, and T is M2 into A plus M2 into G plus F is this tension. Equating both the tensions, F plus M1G minus M1A is equal to M2A plus M2G plus F, and so F and F just gets eliminated. That's good. So I can consolidate what is acceleration. So I can say G into M1 minus M2 is equal to A into M1 plus M2. So acceleration therefore is G into M1 minus M2 by M1 plus M2. If you know the masses of both the blocks, gravity is 10, masses of the first block M1 is 5, M2 is 2, by M1 plus M2 is 7. So it's 10 into 3 by 7 is 30 by 7. And whatever this value gets me, 7 4s are 28, 27 3s are 21 approximately. 4.3 meter per second square will be my acceleration. And now suddenly this breaks, the rope breaks, which means tension becomes equal to 0. That's when the rope will break and both of these blocks will fall down. Okay, so the tension becomes 0. Let's take the first equation only, and it will acquire a new acceleration A dash. So if this is going to break the tension, and so you have F plus M1 into G, no tension minus 0 is equal to M1 into A dash, a new acceleration with which is going to go away. So F plus M1 into G is equal to M1 into A dash. So what is A dash therefore is F plus M1 into G by M1. You can just, just split it up. So it's M1G by M1 plus F by M1. So it will be G plus F by M1. You get it like this? And you know what is G? G is just, let's take it as 10 plus F. Do you know what F is? F is mass into acceleration. We know what is acceleration, initial acceleration. Oh, I have to think about this. Since we found what is acceleration, which is 4.3, can we take it and substitute it here and find let's find what is 4.3. They seem to have given what is F. F is 1 Newton. They have given F as 1 Newton. The force with which this is getting pulled is 1 Newton has been given. I didn't even substitute that. Okay. Now at last I'm able to substitute. So here I can substitute. So it is 1 by M1. What is M1? M1 is 5. So it's 10 plus 0.2. So 10.2 meter. What is it? It's the new acceleration, meter per second square. So that's a new acceleration with which this mass M1 is flying away. I mean when the tension is cut. So let's go to next question. Is the 28th question. Let M1 be 1 kg, M2 be 2 kg, M3 be 3 kg as shown in the figure. Let me see the figure. The figure gets a little more complicated. So you have a pulley like this and you have a mass M1 and you have a thread like this. You know the tension in here will be the same as tension in here. You have another pulley. This is called fixed pulley, and this is called movable pulley. This is called movable pulley. And from the movable pulley, you have two things which are coming here. This is M2 and this is M3. And such a diagram has been given. Let me read the question now. Find the accelerations of M1, M2, M3. The string from the upper pulley to M1 is 20 centimeter. Upper pulley to M1 is 20 centimeter. Then the string from upper pulley to M1 is 20 centimeter when the system is released from rest. How long will it take for M1 before M1 strikes the pulley? Oh, so M1 has to raise up and strike the pulley, which means it has to move through a distance of 20 centimeter. They are asking for the time. Okay. So in this sum, they seem to have given M1 to be 1 kg. Okay. M2 to be 2 kg and M3 to be 3 kg. See, the first thing is go from the bottom. Okay, you know this is the same string which runs through this pulley. So you know this tension has got to be this tension. Okay, so then you know that up is equal to down. So then this has got to be 2t therefore this has got to be 2t. Correct? Because equal and opposite reaction. If this is t plus t is 2t, then that opposite direction has to be on the other loop. It's got to be 2t. Whether it's like this or like this, it's got to be 2t. And so then let's do a free body diagram. In this, this is M2g and this is M3g and this is M1g, and this is going to go up. The question says clearly that this is going to go up and it's going to hit the pulley. If this is going to go up with an acceleration, say with an A1, when this goes up, when this loop goes up, this loop will come down with the same acceleration, A1. When this comes out, it comes down with the same acceleration. In this loop already, this is 3 kg and this is 2 kg. And 3 kg is more heavier. Within this, there will be an acceleration. This is A3 and this will go up, which is A2. When this system is coming down with an acceleration of A1, when this rope is coming down with an acceleration of A1, this is going to go down with an acceleration of A3. This is already going to go up with an acceleration of A2. So this is going up and this is coming down. So the net acceleration on this, can I take it as A1 minus A2? Or should I take it as A2 minus A1? Correct? So let's say, assume that is A2 minus A1 is the net acceleration on this. And in this case, this is coming down. And this is again bringing it down. So how much this has gone up, that much this will come down. Okay, so if this is going to go up with an acceleration of A2, this is going to come down with an acceleration of A2. Already this is coming down with an acceleration of A1. So this block is going to come down with an acceleration of A1 plus A2. So that's the key. Understanding this is the key. If you don't know, you can ask me in the class. So you understand this is going with an acceleration of A1. This is going to come down with an acceleration of A1. Already this is going up with an acceleration of A2 and this is going to come down with an acceleration of A3 as such. So the net acceleration of this is A2 minus A1. The net acceleration on this is A2. Because of this A2, this is coming down with A2 only. We need not call it as A3, but it's A2 plus this A1 is getting added. Correct? Because the same root. So A2 plus A1 is, so A3 is nothing but A2 plus A1. So thus this both the masses acceleration. So let's now do the free body diagram. The free body diagram for this mass, for here, is going to accelerate upward with an acceleration of A1. So you can say upward force 2T is greater than mg. So 2T minus m1 into g is equal to m1 into a. So 2T minus mass is 1. So gravity is g. Mass is again 1 is a. So with this we get one equation. Let's take the free body diagram of M2. You know that this M2, there is a net acceleration which is a2 minus a1, because look at this, I'll tell you something, this is coming down, this is coming down, this is going up. Okay, and we don't know the values of a2, a1 and all, we are just assuming and doing. Okay, so in the sum we seem to have assumed that a2 is greater than a1, right? a2 is greater than a1, but entirely if you see, the system will come down. You have to assume that because this string in here is going to drop down, and that's eventually going to drop both these strings down. Now we have to assume that these two are going to have downward motion, assuming this is also downward and this is also downward. I know this is going to go up, but still this is lowering, so eventually even if it goes up, it is supposed to, the system is going to come down, so that's what we're going to assume. So M2 is downward, so you know M2 into G minus, this is M2G minus this tension T. So taking this free body diagram, M2G minus 2T is equal to M2 into that acceleration is A2 minus A1. Similarly, taking for M3, which is downward, you know, M3 into G minus the same tension is equal to M3 into A2, A1 plus A2. So you get two equations like this. And so you can cancel, let's see, you get M2G minus T is equal to M2 into A2 minus A1. This is M3G. You know the values, right? What is M2? Is 2. So let's assume 20 minus T. Okay, is equal to M2, which is again 2 into A2 minus A1. And this equation is with M3. M3 you know is 3 kg. Yeah, so then it's 3 into 10. 30 minus T is equal to 3 into A2 plus A1. Okay, so now let's go to this one. In this one is the, this is A1, right? M1 into A1. So you get this A1. So from the first one, 2T minus G is equal to, yeah, mass is 1 kg block, is it? Yeah. So this is 2T minus 10 is equal to A1. So I have three equations now. Can I solve it? Can I put what is tension from here? 2T is equal to A1 plus 10. T is equal to A1 plus 10 by 2. That's my tension, and can I substitute that value here? So 20 minus A plus 10 by 2 is equal to 2 into A2 minus A1. So when you take LCM, it's 40 minus A minus 10 is equal to 4 into A2 minus A1. What is this A plus 10? Isn't it A1 plus 10? So it's 40 minus 10 is 30 minus A1 is equal to 4A2 minus 4A1. Okay, taking this that side, bringing this side, I'm sorry, it will become plus 3A1 and plus 3A1 is equal to 4A2 minus 30. Correct. Just trying to get two equations with A1 and A2, that's all. So taking it this side, or you take it that side also, 30 is equal to 4A2 minus 3A1, and that's my first equation. Similarly, you can take this and substitute in this equation. 30 minus T itself is A1 plus 10 by 2 is equal to 3 into A2 plus A1. So it's 60 minus A1 minus 10 by 2 is equal to 3 into A2 plus A1. So 60 minus 10 itself is 50 minus A1 is equal to 6 into A2 plus A1. 50 minus A1 is equal to 6A2 plus 6A1. So you get an equation 6A2 plus 7A1 is equal to 50. Solving this and this, you can get what is A1 and A2. What is the first equation? Minus 3A1 plus 4A2 is equal to 30. Then 7A1 plus 6a2 is equal to 50. And so eliminating into 3 into 2. So it's minus 9a1 plus 12a2 is equal to 90. 14a1 plus 12a2 is equal to 100. So now this is minus this get cancelled. 14 is 23a1. Minus 23a1 is equal to minus 10. So a1 is equal to 10 by 23 meter per second square. I should check if I get this answer correct. Okay, if this answer is correct, then I'm done. Yeah, it's correct. And so that's a1. Substituting, you can get what is a2. So thus you can find the tension in every rope also. Such a beautiful sum. So and then they had asked for time taken. So basically you found what is a1, and that's this a1, and this pulley has to strike at s is equal to ut plus half at square. Correct? You assume initial velocity 0 is half into, we got the acceleration, which is whatever this value of a1 is. You can substitute 10 by 23. So s is equal to ut plus half at square. Where was I writing that? So s is equal to ut plus half at square, where u is 0. Half into a is 10 by 23 into time square is distance. They have given the distance to be 0.2. Just cross multiplying this, you can find the value of t, which will turn out to be 0.25 seconds. That's it. I'm not able to do much more than this. Manage with this concept and try to understand the other questions.